This lesson we're going to talk about the law of sines and then later on the law of cosines. And we're going to use these laws to find unknown parts of a triangle. So the definition of the law of sines. So remember in the previous lesson we talked about area of a triangle and three different forms of its formula. But if we take each of these formulas and we divide them by 1/2 ABC, what happens is we can cancel all the halves. Here we cancel the A and the B. Here we could cancel the A and the C. And here we'd cancel the B and the C. And what we're left with is the sine of C is to C as the sine of B is to B as the sine of A is to A. And basically we'll talk about angle A and side A being pairs of each other, the angle on the side opposite that. So when will you use the law of sines? And you can use the law of sines anytime you have a pair, meaning an angle and the side opposite the angle. For example, angle A and side A, or angle B and side B. So for example, let's say I've got this triangle. And the law of sines does not have to be a right triangle. You can use it for any triangle. Let's say I've got this side to be 6, this side to be 32 degrees, and this side to be 11. And let's just label this ABC. So you can see here we've got a pair. We've got this angle C and we have side C. We have angle, we don't know angle B, we do know side B to be 11. So according to the formula I can do sine of 32 degrees is to 6 as the sine of angle B is to 11. Now this is a proportion. So as a proportion I could cross multiply, and so I would have 11 times the sine of 32 is equal to 6 times the sine of B. Now at this point I could divide by 6, and the sine of B would equal 11 times the sine of 32 divided by 6 is 0.97. But again, I'm finding an angle measure. Now remember, finding an angle you would use inverse or sine inverse of 0.9715. And I would get angle B here to be 76.3 degrees. All right, and then to finish this out, I would need to find angle A. Well, I already have two of the angle measures. I have B and C. There's 180 degrees in the triangle, so I can always easily go 180 minus 32 minus the 76.3. And therefore angle A must be 71.7 degrees. Now I have side A left to find. Well, I can still use that proportion because I still have that pair. So I could go sine of 32 is to 6 as the sine of 71.7 is to A. Now to find side A, I would go 6 times the sine of 71.7. Divide that by the sine of 32. And I would get side C to be about 10.7. So in this particular problem I found angle B, I found angle A, and I found side A. Now you always want to take a few moments and make sure that the largest angle is opposite the largest side, which it is and the smallest angle is opposite the smallest, and the middle angle is opposite the middle side, which it is. Here's another example. Let's say I've got a triangle that looks like this. This is 67 degrees. This is 38 degrees. And this side's 11. And let's label this ABC. Alright, so here's my pair. And labeling the other side, this would be side C, side A. I do have a pair, so now using law of sines, I could just do sine of 67 is to 11, as a sine of 38 is to C. Solving for C, I'd go 11 times the sine of 38, cross multiplying, divide by the sine of 67, and I would get side C to be about 7.35, or 7.4 if you wanted to round it that way. Now solving the rest of this, I do need to find angle A. Third angle is always easy to find. Let's just take 180 minus both of those other angles. So 180 minus 67 and minus 38 is 75 degrees. And then again, I can use law of sines. So I'd have sine of 67 is to 11, as the sine of 75 is to side A. So how am I going to get A? I'm going to take 11 times the sine of 75 and divide that by the sine of 67. And that would be about 11.5. Once again, largest angles opposite the largest side, smallest angles opposite the smallest side, and it looks good. Now we also have something called law of cosines. Now there is not an easy way to derive this formula, but the formula is basically c squared equals a squared plus b squared. So it starts out just like Pythagorean theorem, but then minus 2ab times the cosine of c. Now we could also write it in this form: b squared is equal to a squared plus c squared minus 2ac cosine of angle B. Or we could say a squared is equal to b squared plus c squared minus 2bc cosine of A. Just different forms meaning the same thing. When can you use this law? Anytime you've got two sides and the include angle, or if you have all three sides of a triangle. If you have all three sides, and this is just a form of the original law of cosines, the cosine of angle C would equal a squared plus b squared minus c squared all over 2ab. Okay, so examples of law of cosines. If I get this triangle, and I label this one, I've got two sides, I've got the included angle, so I could find side B. So now b squared will equal 5 squared plus 12 squared minus 2 times 5 times 12 times the cosine of 31 degrees. And if I put that all in my calculator, 5 squared plus 12 squared minus 2 times 5 times 12 times the cosine of 31, I get 66.13, about 66.14, but that's b squared, so to get b, I'm going to take the square root of that answer, and I would get about 8.13 for side B. Now at this point, law of cosines is a little more to remember than law of sines, but at this point I do now have side B, so I do now have a pair. So to finish the problem, I could use law of cosines and just go sine of 31 is to 8.13 as the sine of, let's say A is to 12. Cross multiply, so I'm going to take 12 times the sine of 31, divide that by 8.13, and then take the sine inverse of that. Sine inverse of 0.76, and I would get angle A to be about 49.5 degrees. And then how would you get angle C? Well, I got the other two angles, so I just go 180 and subtract off the other two. And angle C would be about 99.5 degrees. Now, what if you got three sides? So let's say I've got a triangle, and I know the three sides are 5, 6, and 7. All right, to do this, I'd always find the largest angle first. So I'm going to find, no matter how this is labeled, let's say it's ABC, I'm going to find angle A first, the largest one. Now, remember that the formula is the cosine of, if it's A, which is the angle I'm trying to find, then on the top I'm going to have B squared plus C squared minus A squared all over 2BC. So this variable and this one needs to be the same, the one you're subtracting. So in this case, the cosine of A is going to equal 6 squared plus 5 squared minus 7 squared all over 2 times 6 times 5. If I do this on my calculator, got 36 plus 25 minus 49 is 12. I'm going to take 12 and divide by 2 times 6 times 5 is 2 times 30, which is 60. So I get the cosine of A to be 0.2. Now I'm finding an angle, so I would use cosine inverse. And I would get about 78.4 degrees for angle A. Now, once again, once I do that, I've got a pair. I've got the angle A inside A. And so therefore I would do sine of 78.4 is to 7 as a sine of B is to 6. Do my cross multiplication. 6 times the sine of 78.4 divided by 7. Take the inverse sine of that because I'm finding an angle measure, and I would get 57.1 degrees. And then how do you find that third angle? Just like we always have. Once you got two of them, let's take 180 minus the other two angles. And the other angle must be about 44.5 degrees. That's solving a triangle when you have all three sides. Another example of that one, just to get you started here, let's say I've got this triangle. Again, this would be the angle I'd want to find first, the largest angle. So I'd start out with cosine angle A. Then I'm going to have 6 squared plus 8 squared minus 11 squared. On the bottom needs to be 2 times 6 times 8. Once again, this is angle A, and this is side A. So if I do that math, I've got 36 plus 64 minus 121. I'm going to divide that by 2 times 6 times 8. Gives me a negative value, but if I do inverse cosine of that answer, I get that angle to be 102.6 degrees. Then, again, I'd have a pair, and I could use law of sines to finish the triangle.